The word polar and polarize tend to be used more in chemistry, but in electricity we're going to hear them a lot, so I want to review them. Polarize is the act of making something polar, and something that's polar has a plus and a minus side. So when you polarize something, you're separating it into opposite charges within the same object or molecule or even atom. So like this Coke can is usually neutral, but if it's subjected to certain pressures or forces, the pluses will go to one side, the minuses to the other. Here's an example of a metal plate. This negative rod is inducing the negative electrons to go down and the positives to stay here. So the metal plate then takes on a plus side and a minus side. It is now polar. Let's take a look at this a little closer. So if I have an object and it has maybe thousands or millions, billions of atoms, I'm going to say it has 4 atoms. And each atom has a proton and an electron. So this is kind of a made up material and made up atoms here. But proton, electron, you have 4 protons, 4 electrons, 4 positives, 4 negatives. It is neutral, right? But if we put a charged object over here with a strong negative charge, it's going to induce or cause these negative electrons to move far away from the negative charge here. But let's just say this is a conductor for now. And if you don't know what I'm talking about, see my conductor insulator video. But in the conductor, the electrons can move, and they're going to run to this side of the object. Now at this point, the object is still neutral because you have 4 negative charges and 4 positive charges. But this side of the object is partially negative and this side is partially positive. It is almost like becoming a magnet in a way. And so this is now a polar object. Atoms can also become polar. So this is an atom here with 2 protons and 2 electrons. And say we do the same thing. We put a heavily positive charge this time on this side. If we put the positive on this side, the electrons, which usually are pretty equally distributed, are going to actually favor the left side now. They're going to get drawn to that positive side. Now they're sometimes going to be over here. They're going to be over here sometimes. But for the most part, they're going to be on this side. And this is going to give this atom right here a partially positive side on this side and a negative side on this side. So the atom itself has become polarized. It is now polar with a plus and minus side. Now polarization helps us understand some phenomena. If you have a balloon and you rub it on a wool, the balloon tends to take on electrons. So it's going to take on electrons. It's going to become charged. And this is a balloon. So this becomes negative. And if you put it next to a wall, which is usually neutral, the negative charge is going to induce these electrons to go as far away as possible. If you bring the balloon close to the wall, the negative side here is going to cause these negatives for each of these atoms to shift to the right just a little. They can't go too far because the wall is not a conductor. But just enough this way, and now the wall is going to take a partial negative and a partial positive side here. And that's how the balloon will actually stick to the wall, because the negative and the positives will attract. Another example of where polarity will be the cause of a certain phenomena is with this idea of bending water. So if you have water just coming down straight, water is polar because the hydrogens have less affinity for the electrons than the oxygen. Oxygen very much wants the electrons. So this actually creates a partial negative side and a partial positive side for water. So when it's coming down, if you put a negative balloon here, basically a negative charge here, it's going to cause the water to turn. So if the water is this way, these are H's, hydrogens, and here's your oxygen, and it's coming this way, it's going to cause the hydrogens to bend the molecule sideways. It's going to turn it. So we have the negative side here and the positive side here. And that slowly is going to cause the water to bend, as you can see happens here. So once again, polarity becomes very important when you're looking at electrical phenomena.